greetings to everyone who has joined and will be watching afterwards or listening. We want to welcome you to our today's session. We are really keen to learn about additives. So Lubezine, as we all know, and them that don't know, it's basically a professional magazine that handles matters concerning lubricants, maintenance, and it's disseminating information basically to Africa, but now globally. So we are privileged that we started the webinar series, basically sessions like this to bring out people in the industry, professionals in the industry to give us insights on various topics in the industry, especially on lubricants and maintenance. So today we are privileged to have John Fitton, who is a seasoned mechanical engineer with deep expertise in internal combustion engines, petroleum products, and tribology. He holds an MSc in mechanical engineering and automotive option from the University of Cape Town and has built a career that bridges engineering, research, fuel and lubricant technology, and even business intelligence. He has been pivotal. He's played pivotal roles across the petroleum engineering consulting sectors, blending deep technical expertise with strategic leadership. He served as a technical service manager at BP, South Africa, Sasol Fuels Technology, where he led fuel audits, product development, and national fuel strategy initiatives. He's the founder of ONFO Consulting, where he has transformed complex technical data into actionable business intelligence. His work with CPS Chemicals and IMCD Oil Tech, where he currently is, positions him as a key supplier and advisor in petroleum, additives, and lubricants across Africa. Early in his career, he contributed to research on internal combustion engines at Volkswagen, South Africa, and Stellenbosch University, solidifying his expertise in mechanical engineering and tribology. Nice profile. Fitton, John, welcome.
Thanks, James. Thanks for the nice introduction.
I hope I've done justice to your profile.
Thank you very much. Thanks for the opportunity, and yeah, welcome to all the attendees.
Great. So I'll start with the first question. I think it's good to just understand what are additives and why are we using them, and just put some light on what additives are and how important they are in lubrication.
So yeah, thanks James. Good question, and we could spend a couple of days discussing that, because it is quite a complex topic, and it all depends on the application that you use in the lubricants in. But really, additives are required to enhance the base oil. So we use various additives, typically from 0.5% in certain additives up to about 30% on a weight basis. That goes into base oils that are there to deliver performance. So we need to look at the specific additives that we use that control wear, deposits, oxidation, corrosion, foam, to name just a few. So the common families that we'll come across are the detergents, the dispersants, the anti-wear extreme pressure additives, so your typical ZDDPs, your friction modifiers, viscosity index improvers, etc. So really, we're using the additives and the chemical elements in combination with one another with the base stock to enhance or suppress certain characteristics of the base fluid. And that base fluid is then used or that lubricant is used in a machine, and that's where the interaction between the mechanical components and the chemical components come together to reduce wear, to look after your machine, and to ensure that we are getting optimum performance out of your machine. So yeah, at a very, very high level, various components are blended into packages. So typically we talk about an additive package that is going into a specific application.
So when we talk about additives and we're using it in the lubricant, so who really works on the formulation, and how can you take us through what really the formulation is all about, and then how is it applied when blending?
So good question. A lot of research and cost and development goes into optimizing the additive components into packages to meet a certain requirement. So those requirements are typically set by the equipment manufacturer, or we call the OEMs. Who will set a certain level of test requirements. So if we talk about engine oils, typically additives and formulations are updated in a cycle, typically 7 to 10 year cycle in terms of the additives or the specifications that are changing. And that's due to the machine elements that are changing significantly. So the requirements, or the appetite, as we like to call it, the appetite of the machine, as that changes, the additives and the technologies that we use in those machines need to change. So specifications, performance specifications, are typically set by various industry bodies, the likes of the API, ASEA, and the original JSO in the East. And the additive performance specifications need to be met. So the major oil companies, and really the top four major additive companies, I should say, not oil companies, additive companies, spend a lot of money in researching, developing and optimizing these packages, which is a careful blend of all the various additive components that would go into a formulation. That is then tested both in the laboratory, in the chemical lab, in terms of characteristics, in terms of elements. So that's really the chemical test. So we look at corrosion, we look at chemical elements, oxidation stability, those kind of things. And then it would go to rig testing, actual machine testing, and ultimately field testing to make sure that you are meeting the requirements of the market from a performance perspective. So it's all about looking after your machine and making sure that your formulation, when put together correctly, is looking after the machine. That needs to be a careful blend of the various components. If you have too much of one component and not enough of the other component, that will negatively impact your lubricant. So those recipes or formulations are really put together by the additive companies, get the approval, spend a lot of money getting there, and then those recipes need to be followed by the loop blenders very, very carefully. You can't just swap out one component for another component and expect the lubricant to perform in the same way.
Wow. And asking about Africa, as we are really keen on to know about additives, I've not heard of somewhere in Africa where we are manufacturing additives. Yeah? What could be the challenge? What's really the challenge that we face in that we are not being able to, manufacture additives? We are basically a net importer of additives in Africa.
Yeah, that's correct. So I'm not aware of any additive manufacturing at a large scale in Africa. There are one or two manufacturers that are doing at a very small scale for niche applications. But generally, the top four additive companies aren't manufacturing in Africa at all. And the reason for that is that the investment costs are very, very high in a chemical industry. To synthesize these chemical components, these man-made chemical components, to optimize and to do all the development and the test work that's required to meet a certain specification. So typically Africa relies on importing the additives into the region, which are manufactured in Asia, in Europe, and in America. So various parts around the world, depending on where the raw materials are abundant. And then we put the finished fluids together in lubricant blend plants, which are typically present in the country, on the continent. So really it comes down to scale and supply chain. So it's all around reducing costs. And if we can manufacture additive in one or two locations for the world where the volumes are the highest, where your raw materials are available, where there's a complex chemical hub of supporting industries, then that's typically the way that we do it. So you'll find components that are manufactured around the world before they're put into packages are often shipped as components from Asia to America or Europe and vice versa, in terms of optimizing your supply routes, sourcing the correct component that are required in the additive packages and putting those packages together in the cost-effective way. And the scale or the volume just isn't there in Africa to support that kind of chemical industry, that kind of chemical hub.
Considering the various applications of lubricants, I think we have some very specialized lubricants and greases. An example is food grade lubricants and greases. How different are they in terms of when considering additives that you use when addressing food grade lubricants?
So food, very good question. So food grade, a lot of the components that we use in an engine oil, for argument's sake, or typical industrial applications, a lot of those additives are hazardous. And we need to handle them in a very careful and specific way when we blend in an engine oil and those kind of products. And that's fine when we are handling a lubricant for a machine environment. But when we're talking about food and we're talking about incidental contact or direct contact with food that we're going to ingest, they're very specific requirements. So there are various grades. Typically, people will understand the NSF grading structure, which is really broken up into three categories. So you've got your H1, which is your incidental contact, where that's where you're using a lubricant in a machine or in an area that's in close contact with food, but it's not direct contact. Then you'll have your H2, where there's no contact that's allowed. And your H3, where there's direct contact. So depending on the level of potential contamination with food, there are various requirements and different levels of requirements that are allowable. And that comes from the base oil. So what kind of fluid are we using? Your white oils, your PAOs or your esters that are typically used in food grade lubricants. And really, we're not wanting contaminations. We're not wanting trace levels of contaminations down at a ppm level that can potentially affect us as humans if there is cross contamination into a lubricant. So there's specifications that have been put together that you need to register your lubricant with the authorities if it is going to be used in a food grade application. And typically the NSF or the White Book will list those additives and components. So we can't use certain technologies, heavy metals, and certain metals, ash forming content, etc., that we would use in a normal lubricant. We can't use those in food grade contact products. Then of course the lubricant needs to be manufactured in a plant that is certified and registered as a food grade plant. And that's to ensure that there isn't any cross-contamination from a potential hazardous product into the food-grade lubricant. So really the volumes of lubricant and additives that are going into the sector, although very important, is relatively small. So the technology is not that wide because we can't use all the additive components that are going in. And it's very specific and clear in terms of the route that is going. I do see from time to time a number of people wanting to get into the food grade sector because the margins are higher. So as lube manufacturers or lube marketers, the margins for the lube grade lubricants is quite lucrative because the selling prices are a bit higher. But that's because of the cost of the additives and the complexity in the manufacturing and the supply chain.
And now that you're mixing base oil and additives, in a normal operation, if you were to consider an analysis of the oil, could somebody be able to trace what kind of additives that oil has when you do the analysis? So
yes, we typically would do a fingerprint of the lubricant. So as I said in the start, the additive companies are doing all the test work, and they're really ensuring that if you blend into that recipe, it would have a certain profile from a chemical level. And that would, if it's blended to that recipe, that would ensure that compliance to the performance specifications. So there are trace elements. If we're looking at certain components, so nitrogen, for argument's sake, is used in various ashless fluids, hydraulic compounds, turbine oils, etc. And we can use that as a marker to make sure that we put in the right amounts of additives into the lubricant. So we use that from a quality control perspective. Once the product is blended to a specific recipe with the package, we make sure that that product is homogenized, that the densities are the same at the top and the bottom of the vessel. And typically we need to do that under temperature to make sure that we have correct solubilization of the additive in the package, etc. We can then test that chemically from a quality control perspective to ensure compliance to a specification. And that would allow you to be confident that that product is going to work in the field. You can then monitor those levels in the field to see how that additive is performing. Some additives are going to be sacrificial, which means they get used up or adhere to metallic surfaces. So levels are going to drop off in use. But we can monitor that in terms of how that lubricant is performing in the field. So it assists with a quality control up front and then downstream as well in terms of its performance.
So in terms of interaction, because you've said that the additives could interact with each other, and I'm sure it's also interacting with the equipment itself.
Yep.
How can that affect the performance of the equipment?
So that's where the additive package and design of that additive package is critically important. So we need to make sure that we typically, as far as we can, when we're designing an additive package and a formulation, we'll use additives that have multifunctions. So certain additives are going to assist with anti-wear as well as detergency, etc. So they're handling various aspects. But if you put in too much extreme pressure additive, for argument's sake, in a formulation, it's typically a polar molecule. So that means it is it's going to adhere to metallic surfaces, and it's going to look for space on your metallic surface to adhere to. Under temperature, it would then transform and give extreme pressure properties. So that would then get used up and form into a different compound. But if you put in too much, that additive is going to fight for space on the metallic surface, and then your anti-wear and your friction modifiers and other additives that are also polar might not be able to find space on that metallic surface to give you the desired protection. So it's critically important that these additives are well balanced, that the one additive isn't negatively impacting another additive. And this comes to viscosity modifiers. So when we blend in engine oils, we need to make sure that the viscosity modifier that we're using in that blend is the same viscosity modifier that was used in the original formulation, or the cross-referencing and cross-testing that's been done to allow for other additives. Because those two additives are going to interact with one another and affect the ultimate performance of that engine, be it at high temperature, be it at cold temperature. So if we look at viscosity modifiers, for argument's sake, although they're designed to control your viscosity of your lubricant during the operating window, temperature operating window of your additive, we need to make sure that we're not getting low temperature gelling or high temperature deposit formation that's coming from that polymer that we're adding to the lubricant. So it's critical that the additive components are well balanced, that they're not interacting with one another and falling out of suspension, because the additive's useless if it's sitting at the bottom of the drum or the bottom of the sump of your engine. It needs to be in suspension to do the work. So critical in terms of making sure that additive is well balanced and that not interacting with one another.
Now, before we go for a break, we've had and we've seen some additive packages or containers with product in, and people are, it's been sold that people can, add to your oil to boost your additives. I don't know what's all that about. Do you recommend that, or what is your take on that? Like we've seen ourselves, I remember something called motor honey. Could find people adding on the oil or something. What is that really acceptable based on additives that we have from, of course, formulated from the OEMs and big or additive manufacturers, like, of course, that we know the four big ones.
Yep. So again, a very, very good question. As I said, it's really important that the initial formulation is well balanced, that we are meeting the requirements or the appetite of that specific machine. So by adding aftermarket additives, some of them work, some of them don't. But if we take in a well-formulated product, a well-formulated curry, for argument's sake, if we think about from a cooking perspective, if we have a well-cooked curry and we just add a whole lot more chili to the dish. Chili on its own is adding flavor, but if it's over added to the curry, it's not going to taste very good. Same in an engine oil or a lubricant. If we just take something that isn't tested in terms of compatibility with that formulation, in terms of the operation of that machine, and we just throw it into that machine, it's going to potentially cause problems. It may help if you have a machine that is leaking through the seals and you want to extend the life between services, and you're going to use a viscosity modifier and you just add a viscosity modifier into that, it's going to thicken up that lubricant and we're going to get less leakage for that period of time. But the best product to use for a machine is the specification of a product that's designed for that specific machine under those operating conditions. And that can only be tested in actual machines, on test benches, in the field, and in real life to see the performance. So yeah, I would, as I say, some of the aftermarket additives do work. and it's difficult to generalize, but typically you don't want to play around with the quality of the lubricant that you have in your machine. And make sure that the specification that you put into that machine is what the machine actually requires. So it's far better, rather than using aftermarket additives, is to make sure that you're using a good quality lubricant in your machine element to start off with. As I say, it's critical in terms of the understanding the machine, understand how those additives are going to interact with the machine, and that impacts performance. So, for argument's sake, does a machine element have silver bearings? If a machine element has silver in the plain bearings, then certain additives we can't use. So we can't use zinc additives, which are extreme pressure additives, which are great low-cost additives that perform really well. We can't use it in those machine elements. So the interaction of the additive and the formulation with that machine under the operating conditions are critical. So it's important to understand the operating conditions that machine is operating in, the environment it's operating in, as well as the components in the machine, the additives and components that we're using to blend that product. And then if we get all of that right, we're going to reduce our total cost of ownership of that machine. It's going to save us money in the long run, because that machine is going to wear less and it's going to last longer.
Oh.
So IMCD is a leading global distributor partner, and really we formulating solutions. So we are a formulating solutions provider of specialty chemicals and ingredients. So really we partner with our customers, provide formulations and formulatory support, and have a very wide portfolio range that is across different business units, but a very wide complementary specialty portfolio range. We have a global footprint with local expertise. So it's important to understand the local requirements as well as what's happening from a global perspective. And then we listed on the Amsterdam Stock Exchange. These are just a quick view of where our offices are located. And although Africa seems a bit blank, we operate in most of Africa, specifically all the countries in sub-Saharan Africa. So we are operating in all of this region out of our offices in Kenya, as well as in South Africa, and we're busy expanding our footprint as well. IMCD is broken up into 8 different business units. I'm part of the Lubezine Energy business unit, so focusing really on what we're talking about today, in terms of the supplying the technologies, the formulations in support of lubricants and energy. So everything from fuels manufacturers, chemicals manufacturers, all the way through to lubricants. And then really focused in these kind of areas. It's automotive fluids, your industrial fluids, and then the energies as well. So upstream, downstream, oil and gas, your engine oils, your hydraulic fluids, your driveline fluids, industrial fluids, etc. And yeah, so that's just very brief in terms of who IMCD is. We represent a large number of different principals who are the manufacturers, and we work very closely with those principals to develop technologies. So from an engine oil perspective, we're busy developing and have developed technologies specifically for the African conditions. So our conditions in Africa are different to those of Europe and of North America. So how do we optimize the supply chain? How do we optimize the performance of those lubricants to ensure that we are having fit for purpose additives and components for the local markets? So that's quite key. So the supply chain optimization, is really key in terms of and getting the right products at the right time at the right price into the market, which is critical in specifically in an African market that has different requirements. So our dust levels are, for argument's sake, are very different to that of Europe. So our machines are ingesting this dust. That lubricant needs to control that dust, needs to handle that dust. And we use polymers and we use certain technologies that reduce the wear that dust is causing on the lubricant. And that's very different to what you experience in Paris or in New York or in other areas. So yeah, we're working very closely with the principals to bring technologies to the African market and other markets around the world to ensure performance. So re-refined base oils, RRBOs, are very important in terms of the sustainability and of lubricants. So lubricants or hydrocarbons obviously are having an impact on the environment. We need to make sure that we are not damaging the environment with our used oil. So we're using the lubricant and the oil to improve the efficiency of our machines. But when it's finished, when it's depleted, when it's contaminated, we need to make sure that we are responsibly looking after that lubricant and reusing it if we can as often as we can. So RRBOs are re-refined base oils that are collected and processed in a specific way. So when we process those base oils, we're re-refining those base oils, we're removing all the contaminants, we're removing the nasty elements that are potentially in that base oil. Typically, we're hydrotreating those products again, and we're able to regenerate or restore that hydrocarbon molecule and able to put it back into a lubricant, and it's going to perform almost as well as the virgin base oil. But that's quite a complex and expensive process to go through. If it's done properly, it's more expensive than virgin, typically more expensive than your virgin base oil is. So people are typically taking shortcuts, and that's where I talk about recycled base oil. We come across it quite often, specifically in Africa, where you analyze a lubricant and it has wear metals in it. And it's a new can of product that you've bought, and it's already got wear metals in it, which means we're just taking our used oil, cleaning it up a bit, maybe filtering it, and putting it back into the system. So that's your recycled base oils that should really just be used for furnace oils and those kind of things. And not put back into the lubricant pool, should I say. But more and more work is being done from a sustainability perspective so that we can be less dependent on crude. So the whole RRBO scenario is being developed and developing very rapidly in terms of what additives do we need in those re-refined base oils, and what's the performance levels. So a lot of lubricants have been, or a lot of additive packs have been developed and tested in re-refined base oils. So your re-refined base oils need to meet a certain specification, and those specifications are coming out around the world in terms of how do you test, what's your feedstock, what elements to look out for, what levels of contamination are you allowed, and then what process do you go through. And that talks to sustainability. That talks to reusing and the cyclical economy of these hydrocarbons. So it's critical that the additive package that you are using in the blend of your certified and registered RRBO actually meets a certain performance level. And we're seeing more and more manufacturers and blenders coming out with formally approved base oils or lubricants that come from RRBOs. So yes, it can be done. It talks to sustainability. but we need to make sure that the additive pack, that the base oil is properly tested, properly re-refined to meet a certain specification, and then the additive pack combination is properly tested in the market for the specific application.
Thank you, John, for that. We have about 3 questions. And the first one is, can energy savings be derived from using correct viscosity index improvers?
Absolutely. So if we use the correct, it all depends on application. So you can formulate a product in an industrial gearbox and you can save 5 to 8% energy efficiency if you're using the correct viscosity index improver in that application. But your energy can also come from startup and cool down. If we have less change in viscosity and we're using viscosity modifiers, so the product isn't very viscous when we are starting up, then we're going to save energy in terms of heating up the system because it's not as thick, we're able to pump it around, as well as slightly higher viscosity, so we're not going into boundary lubrication as the product heats up. So yes, the viscosity or the VI, viscosity index improver, needs to be matched to the application, the operating conditions, the temperatures, the environmental conditions that we are working on, and that's critical. That's key from an energy efficiency perspective and reducing wear on your machine element.
Thank you for that. The other question is, are all additives the same from different companies for similar applications?
It's an easy one. No. Okay, so when we design a package, the package is built up of a number of additive components, and it needs to then be tested to a range of specifications. So if we look at an engine oil, typically an engine oil, we're going to run about 22 different engine tests in different applications, different requirements to meet a pass mark. So if we had varsity pass marks 50%, we get a certification, we can use that additive. But some additives are passing at 80% or 90%. Some additives are passing at 50%. So although it meets the specification, they're going to perform differently in certain applications. So I've run many field trials in the past where we're comparing 2 lubricants or 2 additive packages in an application. They both meet the same specification. So the looks of it, if you look at the can and you look at the technical data sheet, they both look exactly the same. But in certain applications, they perform very differently. So it's always important to understand the application, where it's been used, and how are you stressing that lubricant? And certain additives are going to perform differently to others under applications. So short answer, no.
Thank you for that. There is a question on re-refined or recycled base oils. The question is, are they more expensive than the original ones? And if so, why do you think so?
So typically they are. It all depends on, because you need to collect your feed streams. So you need to collect your waste oils. You need to then process it through dedicated plants. Whereas when we're talking about virgin base oils, typically it's very large chemical complexes. Our feedstock is readily available, and we're able to constantly manage that plant based on a constant feed stream. When I'm taking waste oils and I'm processing it, every time I run a batch, that waste oil is different because it depends where it's coming from. So it depends, is it engine oil, is it hydraulic oil, where is it coming from? It needs to be processed in a different way. So your testing is more expensive. Typically your plants are a lot smaller, and then it needs to be certified and put into the marketplace. So typically it is more expensive on a re-refined base oil route. But that will change over time as it's adopted more and more, as there are mandatory requirements, as there are in Asia and other areas around the world at the moment, where there's now mandatory requirements for certain levels of RRBO to be used. Those price points are going to change. So at the moment, from my experience, it's more expensive, but that will ultimately change as we move forward.
Thank you for that. Because of time, we're just going to tackle one last question. There's a question here about what's your opinion about additive manufacturers from China? They offer additive packages and some have approvals.
Yeah, so good question. There are a number of additive companies that are smaller additive companies that are cropping up around the world, and a lot of them have low price points. Some of them are now starting to get approvals, especially in the industrial sector. But as I say, those packages need to be put together, and making a detergent component is relatively easy. It's about putting those components together in a package and making sure that it performs across a slate of base oils, across a range of formulations to a certain level. And that's where approvals come into play. So if an additive has let's say a Mercedes-Benz 228.51 approval, it means it's met all those requirements, and is going to perform. It's going to pass same as another additive from a major oil company to those levels. So it really comes down to the approvals. I see lots of data sheets where there's been no testing. So as long as the testings and the approvals are there, then you can be confident in that technology. But when you get an additive data sheet that says it meets the requirements of, or up to the end user to verify the performance, I would be a little cautious. But saying that, in certain applications, it may work. So it's all about having the right product for the right application at the right time, at the right price.
Thank you for that, John. Those are all the questions we're able to handle now. I'll hand it over to James to wrap up the session for today.
Wow, thanks, Miriam, and thanks, John. Maybe a quick one. Just want to remind our audience and the people who are listening, watching, that we also post these sessions on our YouTube channel. That's Lubezine Magazine. So feel free to, of course, subscribe, like, and of course, share. And then also we want to remind you of Lubezine Magazine itself. It's basically a quarter, we publish it quarterly. So you could go to our lubezine.com website and be able to subscribe. When you subscribe, that also you'll be receiving a monthly newsletter, which is called Lub Post. So for now, I want to thank John. Maybe you could have a parting shot before we wrap up.
Thanks, James. Thanks, Miriam, for the opportunity. It's really important to share this information with the tribological community in Africa, and so thanks for these webinars. It's really important to get the information out into the marketplace. And yeah, thanks for the opportunity. It's really important to make sure that we have the right additives, formulations going into the marketplace, because it does impact the total cost of ownership. It impacts the economy of the African continent, and let's move forward and strive for performance. So thanks for the opportunity. Any questions that anyone has, please feel free to contact me either directly or via Lubezine, and we can see where we can assist. But thanks for the opportunity, really appreciate it. And thanks for the platform that you have.
Thank you. Thank you very much. Also, we are thankful for your time and very, very key and valuable insights that you provided. I trust that we can share your email address. Miriam could
Sure.
post, yeah, could post your email address in case anyone would want to reach you after this. Feel free. And thanks so much. I want to thank everyone who has joined in, and wherever you'll be watching or listening, thank you very much. And we look forward to the next edition or issue of our session, which will be towards the end of September. Looking forward to see you there. Have a nice evening, and God bless you.
Excellent. Thanks, everyone. Appreciate it. Take care.
Thank you.